Okay, cool. Recording is going. All right, so let's start off talking about, this will be session 1, talking about fundamentals of Advantech wireless IoT. So there's actually a 6-part course that we can do, I don't know, 6-part series with six different courses. This first, maybe 30 minutes or so, we'll go over fundamentals. So we'll introduce some terms. We will talk about the product portfolio and what is, what's most relevant. Well, and then in the subsequent sessions, we'll get into more detail. So before we do our first break, we'll do this kind of fundamentals course, maybe kind of a 101 type course. And then in the second, just right after that, we'll get into the LTE product line in particular. Okay, so when we're doing this training, actually let me do the full screen here. So sorry guys, just a second. You don't need to see the thumbnails. That's not particularly relevant. It can be kind of distracting. And then if you want to see who's presenting here, let's see if my video works. Hey, okay. All right. That's about as much video of me as you can stand, so I'm going to turn it off. But I'm glad you guys joined, and we'll have some good training here. So, all right, go into presentation mode, and away we go. All right, you can organize this obviously however you want. I would say that there are 3 kind of major categories that we'll cover today. And if I was receiving this training and I wanted to organize it, this is what I would do. I do have links here, and this will be sent out in the deck that have a lot of material in them. So I don't know how your folder structure is set up. If you're coming at this from a new hire or a new exposure to Advantech, then this is maybe how I would get started, or with these product folders, however you'd like to do it. But routers, wireless sensing, and then industrial Wi-Fi. That's how we would do it. I'm just going to quick double check, make sure we're still recording. Okay, we're good. All right. So as I said, today, right now in this session, we'll talk about all these, and then we'll follow up with specific sessions for each one. By session, I mean maybe half hour. So I would say that this is not just, a lot of product training is kind of like, hey, here's this product, here's the features, and next, right? And we kind of go through that. For this training, we're going to do, we're going to focus on a product that's really pretty unique to Advantech. We'll talk about the competitors and stuff, but this is a unique area for Advantech because it's a relatively higher growth area, and it's something where most people who are familiar with Advantech know Advantech as an industrial PC company or automation or embedded type PC company. This communication stuff that we're focusing on is really unique to, well, it's essential for growing your account base, I think. These are great door openers. IoT stuff is a big buzzword, and when you can come in and talk about a lot of the breadth of wireless IoT technology that we're going to cover today, you'll find doors opening and emails, getting replied to, right, with more with interest from customers. Okay, within the industrial IoT, it's no surprise, Advantech has a bunch of different computing and communication solutions out there. What we're talking about today, just to kind of place it, is in the wireless I/O and then wireless communication. Okay, so this is what we're covering in today's training. Okay, let's talk about some new or potentially new technology terms for you. Again, I'm focusing this on what would be more sort of a new hire, so if you've heard of it, just consider it a review. Wizard, okay, what is Wizard? Wizard is a brand name that we developed for a wireless mesh, the tongue twister. Wizard wireless mesh. So a low power meshing protocol that is proprietary to Advantech. It uses, there's Wizard nodes, and they talk to Smart Swarm gateways. So Wizard is
video is not coming through.
The screen share? Okay.
Right. We can't see presentation.
Shoot. Well, thanks for chatting and chiming in. I'm sorry, guys. You know, it's funny. It seems like I either remember to do screen share or record, but very rarely do I remember to do both. So, all right. Now you can see it, I think. All right. We're sharing. Okay. All right. So I won't go back, but I will just, the slides I was talking to, I'll just show you real quickly. So folder naming. Yeah, thanks. Thanks for chiming in there. I apologize, guys. Thinking about how to organize the content that we'll go through, I would consider this. As I said, this is going to be sent out. You'll have links here to Dropbox files or folders that have a lot of like sales kit material and data sheets and things like that. So all in one place. And then you know, Advantech LTE routers, Advantech wireless sensing. I would suggest organizing it that way. And then I was saying, you know, look, this is important for growing your account base. This is new stuff. And then if you want to see a picture of where this fits, if you've seen this kind of all-encompassing graphic from Advantech before, we're in this wireless I/O and wireless communication space. Okay, so those are the slides I was sharing. I am screen sharing and recording. Awesome. Okay. All right. Now back to regular programming here. So Wizard is wireless mesh. It is the only kind of meshing protocol that we support. So we'll talk about other wireless stuff out there, but it's not mesh. You know, I suppose I should have a topology screen here or slide. Basically, mesh just means hopping from one node to another node back to a gateway, as opposed to LoRaWAN, which is point-to-point or point-to-multi-point. So it's like a star topology or a mesh topology. So as speaking of LoRaWAN, so LoRaWAN is stands for Long Range Wide Area Networking. It's an interoperable standard, and we have a training session specifically on this that we'll get to here in a minute. But LoRaWAN is so low power, long range. It operates over 900 megahertz, and it's point to multi-point. Okay, and then you'll see me refer to Cat M or Category M1 and narrowband IoT. These are cellular technologies that require a SIM card, and they are also low power, low bandwidth IoT options. Okay, so that's introducing all of these all at once, or a few new terms, and that's fine. But to simplify it even more, you know, you might just think about, okay, there are two categories, right? There's some that require a SIM. There's some Advantech products that require a SIM card, the routers, and the sensor, the Cat M sensor nodes on the left-hand side of this screen. And then there's some products that don't require a SIM card, right? So these would be your Wi-Fi access points and nodes, LoRaWAN, Wizard. These don't require a SIM card. Okay, so to put this all together, kind of in a picture, what I think has been helpful, and if it's not helpful, just ignore it. But basically, you know, the way that we explain this is the cellular network operators. They think of their data network like a highway in some sense, right? They build this highway, they charge customers to use it just like a tollway, right? Like an express lane. And the SIM card is your toll, right? So our Smart Start, Smart Flex, ICR, these are all SIM-based products that use this high-speed cellular fast lane, okay? The carriers also, like all highways, there's kind of the service road here, okay? So it's part of the highway infrastructure. You still have to use a SIM card, but you can't go as fast, okay? And it doesn't require as much power to use it, all right? And that's kind of like a service road. And that's LTE M and narrowband IoT. We'll talk about those. But that technology is used by our WISE product line and our ICR. On the far right-hand side, imagine a bike path, okay? No SIM card required. And this is, unlicensed technology space here, Wi-Fi, Wizard Mesh, LoRaWAN, that's all using this adjacent bike path, okay? So to try and understand all of the different technologies all at once, there's no real perfect, metaphor for that. This is about as close as I can get. And if it's helpful, great. If not, then let's move on. Okay, so there's a trade-off between range and speed and then power consumption. That would be maybe another graphic to put on, or another axis to put on here. What's important about this is as follows, right? Wizard being meshing and low power, it can be in this, it's certainly low data rate, like super low data rate, just little bits and bytes of data, relatively lower or more, more shorter range, but it's okay because it meshes. Our Wi-Fi products, similar range. I could scoot this a little bit over to the right. Wi-Fi speed, and I think most people are familiar with the trade-offs for Wi-Fi. In this newer technology anyway here, know that LoRaWAN is low data rate, but long range, right? We could really put LoRaWAN out in the 3 to 5 mile range, okay? And then the LTE technologies are certainly, the range is dependent on the location of the nearest cell tower, right? I don't need to explain, LTE signal strength and coverage and so forth. You guys are familiar with that. Okay, hey, just real quick, it does sound like someone might not be muted. If you want to just maybe make sure that you are muted, that would be good. And I'll mute, sorry. So here, you guys did help me out earlier with letting me know that I wasn't sharing screen. So I'll check on the, let me check the chats here. And make sure I'm not missing anything. Okay. Yeah, Zach, good question. 802.15 mesh. Yes, Zach, it is 802.15 mesh for Wi-Fi 802.15.4. It uses like a dust, almost like a dust protocol. And I'll cover more of that here in a minute. Okay, interface comparison. So this is the template that we're going to use. Don't worry, there won't be a bunch of charts like this. There's a lot going on here, but in presenting, this is really helpful when we're in the position of doing kind of a first call or an introduction to Advantech for a customer who's specifically interested in wireless, because it shows, okay, look, we have this proprietary mesh, all the way to Wi-Fi and a lot of things in between. And then what I'll do is in the next few slides is I'll break down, take one column at a time and show the product support we have and some example applications, okay? And that's basically the rest of this session, just breaking down each of these. So that's what you're getting into here. Okay, I gotta keep myself hydrated here before I start coughing. On the Wizard Mesh, perfectly fine indoor or outdoor. You'll see the product images here in a second. Very rugged, class 1 Div 2, IP65 or 67, but certainly rugged outdoor nodes. As I said, mesh topology. That's where the nodes act both as kind of coordinators and nodes, to use a Zigbee analogy. But really great for industrial process and equipment monitoring. So when you need to validate just bits of data, more limited range, point-to-point range, but of course because it's mesh, that's a mesh network in an industrial environment with Wizard is actually pretty robust. And then this pays off in the product sense with the node and the Smart Swarm gateway. Okay, that's Wizard Mesh. LoRaWAN. No reason it can't be indoor, but our product, and I'll explain this a little later, but our product fit is probably best for outdoor. Point-to-point, point-to-multi-point, so star topology. We've got LoRaWAN vibration monitoring equipment, so think about like condition-based monitoring or even predictive maintenance, I guess. Big industrial campuses, water treatment facilities. This is great for our LoRaWAN solution. Long range, as I said here, lower data rates, You're not doing control type applications with really any of these, maybe with Wi-Fi, but this isn't a control thing. It's really a sensing and data collection thing. And then the WISE node and LoRaWAN gateway here. And again, I'll show those. Okay, in the middle here, LTE Cat-M, narrowband IoT. It's, I apologize, it can be a little confusing. These technologies are almost two sides of the same coin in a sense, in the sense that a Cat-M radio will support narrowband IoT. These devices that I'll show you here, they support narrowband IoT. There are trade-offs that are probably too detailed to get into at this stage of just introducing it, but just know that this is like really low power, low cost LTE technology for sensing and data collection. Okay, that's what this is. Certainly outdoor, although there's no reason that, we do have applications where, and I'll show you somewhere, this is used in bunkered, elevator control rooms and so forth. Cellular, tower to node technology or topology. The number of applications for Cat-M, you can't really summarize it. If you go to Best Buy and look in the smart home section and you find like a smart dog collar, you can find smart dog collar, smart dog collars with LTE Cat-M on the shelf at Best Buy, all the way to smart metering applications to polling Modbus registers. So there's a lot of applications for Cat-M. Really 1 megabyte or less than that, that's for Cat-M. Narrowband IoT is even less in terms of data rate. And then both the WISE 4671 and the ICR 3211 have this technology. Okay, LTE, I really, the training after this, so we'll do this for another few minutes and then we'll switch to focus specifically on LTE. LTE and Wi-Fi, in my opinion, are the two technology areas that are most likely to make you money. All right, they're most likely to be, they're most widely used in production. They're most likely called out, or typically called out on RFPs. They're the what would you call? I mean, they're the main thing you want to know and be comfortable with in your toolbox for Advantech wireless IoT. Okay, so you all have LTE phones. You don't need me to explain the technology at its introduction type level. When I say remote machines, I know that's a very general term or broad term. For a lot of our wireless IoT applications, and I think specifically our partners who are focused on automation, remote machines means you've got a customer who's building, well, a machine, a robotic trash sorter, a pallet wrapper, a tunnel washer, take your pick, right? There's a lot of different, the type of customer I'm talking about. And they do 50 to 1,000 a year. LTE gives them a drop-in remote access, path to that machine, and they can use that. I don't want to spoil the next training because I'll talk more about this, but this is this is like a major growth area. A lot of other vendors in this space. We have to focus on some differentiation, and I'll talk about that. But this is a key area for us. Relatively low speed in different LTE categories. That's another thing to introduce, and I'm sorry, I really don't want to overwhelm you. There are different categories of LTE. Your phone is probably Cat 6 or Cat 12, Cat short for category. We have category 1 to category 4 and so forth. And then the Smart Start, Smart Flex, and ICR. Okay, Wi-Fi needs no real introduction. What's a good Wi-Fi application for Advantech? Production lines, shop floors, typically like a stationary application. I'm joining an enterprise network. I'm joining a production Wi-Fi network and a higher speed and the WISE 4000 line, specifically 4220 and 4050 or 60 supporting Wi-Fi. Okay, so far so good. So now let's get into specifics of each, and then we'll summarize at the end, and then we'll move to LTE, because I really think LTE is something you'll find useful. But Wizard is actually, you know, Wizard can be an ace in the hole. This is a very unique technology that's used to solve challenging like RF environment type applications. Okay, so on the left-hand side, you'll see this is just copy and pasted from the previous slide with the different stats, if you will. But here's a picture of the devices themselves. So the Wizard node comes in this cool enclosure. I say cool because it's, you know, IP67. It's got a magnet built into the base, so you can slap it on a bin or on a panel, or you get the idea, anything metal, right? Good, you know, in terms of like being rugged interface, like conduit or M12 connectors, and push button configuration. Okay, so this is a super cool product, and then it talks over that 802.15.4, that wireless mesh radio protocol back to the Smart Swarm Gateway. Smart Swarm Gateway then establishes that connection to, quote unquote, the cloud, right, the internet, either through a Ethernet port or through a cellular radio in this gateway. Okay, so can be battery powered. I mean, imagine, right? No wiring, battery powered. Stick it on the side of something, connect it up. It talks to the gateway, and you're getting data. Very, very cool, very unique. Yeah, I'm just, okay, let me check on the chats. No questions so far. Hope I'm not losing you guys. This is a long training session, so I hope everybody's staying engaged here. Yeah, Zach, how long do batteries last? Up to 5 years. So it obviously depends on the pull rate, but good question. These batteries will last, I think the stated rate is 5 years. Obviously how long the batteries last is kind of can be a detailed question, but it's multi-year battery, let's put it that way. And we're happy to talk about specifics here offline. Alrighty. Oops, just want to make sure I'm not missing any chats. Oh yeah, thanks, cool, okay. All right, there we go. Okay, so that's Wizard. All right, we're good here. Okay, example application. So I want to monitor, let's say, look, the business case for monitoring, for any environmental monitoring, or how should I put this, IoT data collection application can vary. It can be environmental, regulatory, or let's say regulatory compliance. It can be optimization, cost reduction. In this particular case, this is all about regulatory compliance. So I've got a smart quarry, okay, and there are things I need to know about this quarry level, the level of my hoppers, how my motors, my rock crushing motors are running, vibration, temperature, and I need to send that up to my some kind of data historian, some kind of way to collect the data and establish that I'm operating in compliance here. So if I was to do this by laying a bunch of wires, that would be very, very difficult. So I'm going to think about wireless. Okay, so when I think about my wireless options, what wireless options would I have that are low power, such that they're battery powered, so I don't have to run wires, power lines. This Wizard mesh makes a really compelling solution. This picture doesn't quite do the actual environment justice, but talk about electrical emissions and metal and rock and remote, and this quarry is it's just super ideal location for that mesh, Wizard mesh technology. Okay, LoRaWAN. So this was the second to the left here on our previous or on our original table there. All right. if you've never heard of LoRaWAN, you can Google it and you can do, it's worth reading about. I think a year and a half ago or so, we started talking about LoRaWAN with partners, and it was like, I never heard of LoRa and LoRaWAN. And so it feels like it's relatively new in the US. The reality is that I don't know that, just speaking about like the adoption, certainly I think the adoption is probably a steeper curve in Europe where the technology was originally developed. I actually think that it's either Brazil or Argentina may have the highest number of LoRaWAN end nodes in the world. They're used for car, I think it's either theft detection or like insurance, usage-based insurance. They use it for cattle tagging. You know, the LoRaWAN cattle tags. When you go into a parking lot, let's say a parking garage with multiple tiers, and you see the lights up above, like green and red lights indicating open parking spaces. In many cases, that's using LoRaWAN technology. So we will do a session specifically on LoRaWAN. At this stage, let me just point out a few of the products we have that support LoRaWAN. Remember, LoRaWAN is, the key here is long range. Again, I'll get into this, but at this level of introduction, I just want you to know, long range can be low powered, right? For low power or power sensitive applications. There are some security characteristics that make LoRaWAN attractive, and it's set up to be its own network. So you can set up your own LoRaWAN private network. I'll show that later on here. Okay, cool. So product-wise, you've got the 4610. This is a sensor node talking back to our gateway. You've got the Wizard form factor. I apologize, this is confusing, but basically it's that same Wizard form factor, just with LoRaWAN radio inside of it, talking to our gateway. You've got a wireless vibration sensor, LoRaWAN vibration sensor, that talks to the gateway, or these can all talk to any third-party LoRaWAN gateway. So more on that later, but just know that this is it's interoperable. So all of these LoRaWAN products will work with non-Advantech LoRaWAN gateways as well. And our gateway will work with non-Advantech sensor nodes. Cool. So far, so good. All right, let's look at, see if I can change here. Okay, case study. So if you see in the bottom left-hand corner, the 2410, the WISE 2410, really, I think makes the kind of the coolest, application stories that they're very easy to understand. So in this case, we've got the 2410 mounted to, it comes with these pre-drilled for these, it's got I don't want to call it a set screw, but basically a post, a threaded post that screws into pre-drilled holes on motors. It can be magnet mounted as well, or adhesive mounted. And it reports vibration data to our WISE 6610, which can then be used in a whole number of different applications, Node-RED or specific, databases, frankly. What's key here, though, is that it's reporting the data, and we'll talk about this particular product later, but it reports this data in an ISO standard way. And so depending on the size of the machine, you can essentially see where you're in a good state of operation or an unacceptable state of operation. I want to say more about this, but we're gonna save it for the LoRa session, and we'll focus on it there. All right, Cat-M and narrowband IoT. So again, remember, now we're in this, we're off of the bike path now, okay, and we're on the service road, if you remember that analogy from before. So we have to have a SIM card for this, and these use, Verizon, AT&T, T-Mobile, really any network in the world that has Cat-M and narrowband. I'll talk about that. Cat-M is got really great coverage around the U.S. Narrowband IoT is maybe a little less, but we can talk about that. So I put a SIM card into either the sensor node or the cell router. I provision it to talk to my cellular carrier, right? And then these devices are right on the internet, right? So there's no gateway involved. It's talking right for the cell tower icon really just means that carrier's network. Different options for interfaces. I am going to talk more about this, but what's important at this stage is to know that Cat-M and narrowband are new technologies. They tend to, if this is very unique, so if I have a customer who's asking about this, just know that we have, our solution is one of probably maybe 8 to 10 that are kind of available globally, and specifically in this kind of form factor, or this maybe general purpose I/O sensor node. So yeah, you've got something that's definitely going to be a door opener in this technology. A really slick application for this would be, think about a water, what would you call it? A water treatment system almost, right? Where, a lot of what's been, from the point flush the toilet to the point where that water is then redistributed, it goes through a ton of treatment. A lot of that's right, it's just gravity fed, but there are key points on this in this treatment system where measurements have to be taken, levels need to be checked, sensors need to be read, and so forth. And so dropping in a 4671, 44 is not for the US, so don't worry about that, but 4671 on an LTE network, you don't have to set up a radio network, you don't have to worry about where you're pointing your antennas and the towers and things like that. You just know, okay, I'm going to have LTE coverage, I can use this sensor node. All right, the LTE router. So again, I said this was something to focus on. I certainly believe that. That's why it's the second session that we'll do. There are 3 hardware form factors, I guess, for the LTE routers at Advantech. These all use the same kind of, the same like web UI, the same basic software architecture. They use different LTE radios and have different interfaces. But the point for all these is the same. At the introductory level, what's important to know, these take a SIM card, just like the previous Cat-M and narrowband products. They are higher speed than those. This is the highest speed, save Wi-Fi. These are the highest speed LTE devices. They support both, they're fully certified for operation. So you'll see some products, I mean, even some of the Advantech portfolio, but certainly other vendors will have an LTE quote unquote option, but it's not gone through at the dedicated carrier certification process, which these have. And then two other things, and then I'll talk about it more in a minute. They work on any carrier in North America, okay? And they're not just routers, but they've got, think about like edge intelligence. So different protocol conversion. I want to pull Modbus registers, or I want to do some Python scripting. I'll get into that in more detail later, but these are both LTE, network appliances, and also in the sense that they have a full routing stack and are very, a high security network appliance, and also a gateway with edge intelligence. So laying out all of the SIM-based products here. So there is the ICR, there's Smart Start is LTE category 1. Lower, category 1 just means it's limited in speed. Simple interface set there, Ethernet, serial, optional 802.11 BGN, polycarbonate plastic, enclosure, support for all carriers in North America. Smart Flex, faster LTE, more options for interfaces, so you can have up to 5 Ethernet ports. GPS is standard, USB and the storage options are standard. Optional serial, Wi-Fi, and then PoE, that's an important one. So optional PoE, and same carrier set there. The ICR is both the fastest and the slowest, oddly enough. So it's got super high speed. You know what? Sorry. I gotta fix that. That's really bugging me. Sorry, guys. Fastest 150 megabytes, right? Yeah, confuse you there. And the ITR 3211 is Cat-M, and optional GPS and Wi-Fi. Otherwise, just Ethernet, metal enclosure. Okay. And the WISE is the sensor node that I talked about before. And then as a teaser, we'll talk about this software set that we have. Very cool stuff. Completely, production ready, and a very important value-added way. This is something that's called out in RFPs. This, how do I essentially manage it? And we'll talk about that. All right, kind of a cool example story here. So this is, you could call it predictive maintenance or condition-based monitoring or whatever, but this is a great industrial IoT success story with a company that does essentially data, well, what would you call it? Monitoring and then data analysis and presentation for they call it rotating and reciprocating equipment. So basically, in this case, we're talking about a compressor, right, on a natural gas distribution line. So these compressor turbines are spinning a lot, as you can imagine, and this customer has a dedicated controller that they designed that's connecting to their sensors that they designed. But how do I get secure, reliable network coverage and network connection no matter where I am, provided there's an LTE network? That's where the Smart Flex, you can see our device there, that's the gateway. That's where it comes in. And so this customer used Python script on the device to send data to Microsoft Azure. He needed something that worked across all carriers. Now, I'll talk about that in a second, but just know that this device, the single part number will work on all carriers in North America. That's really important. Needed class 1 div 2, and then industrial temperature ratings, right? Because a lot of times the Wi-Fi, you'll see kind of the split operating temperature spec, right? Where the operating spec is one range for LTE, but then if you add Wi-Fi, that range shrinks. That's not the case with the Smart Flex, so that was important. So again, that's just kind of a story about that. Zach had a question here. Yeah, thanks, Zach. I will talk about 5G, and I will not really talk about CV2X, but I'll tell you what, hold that thought. We'll get there in the next session here. We'll talk about 5G. Okay, all right, so review. Not going to go through this all over again, but you know that we covered Wizard Mesh, Advantech proprietary mesh. We covered LoRaWAN, long range point-to-point, 900 megahertz. We narrowband and LTE, which are, and CAT-M, which are LTE-based, either sensor networking or network appliance, in the case of the higher speed LTE, and then Wi-Fi. All right, let's do this. Let's go right on to Advantech LTE. We're doing okay on time, and since we're doing this right on top of the one right on top of the other, I won't go back over through the review stuff. I had done this originally. I had done it in a kind of like 1 or 2 week, with 1 or 2 week gap between each presentation. But since and I would review it. But since we're doing this bing bang boom, we'll just do it that way. All right. So let me switch slides here. Stand by. And I will remember to share my screen this time. Okay, resume share. Okay. All right, just a second. Okay, cool. So we did our first 30 minutes or so. I guess that went a little bit long, but I'm trying to keep each of these to 30 minutes. We did our first one just now, and we are moving on to focus on LTE. So I'm sharing and recording. Okay, life is good. So remember I said that LTE is an area to focus on. Okay. And it's one of the areas of highest growth for Advantech. I think it's going to be one of the areas of highest growth for you, our partners. And so let's get into this. We'll spend, okay, we're going to talk about the gateway portfolio. We're going to talk about competitive positioning here, and we will, Zach, to your question about 5G, we'll talk about that as well. All right, so this, again, this is all LTE, SIM-based stuff that is good to know. All right, so we talked about 2 different categories. Some need a SIM, some don't. We're talking about the ones that do, obviously, today with LTE. Today we're talking about this data the high-speed fast lane and then the service road. We remember that metaphor because we're talking about we're not talking about the sensor products today. I want to keep this wise, although it is LTE Cat-M. I want to keep it a little bit separate and talk about it in the context of our other sensing devices, and just talk about the kind of gateway or network appliance type router devices in this session here, okay? All right, so, and by the way, you guys will certainly get all these decks. I use this one in presenting to customers who are interested in our LTE routers. Maybe they're using a competitor today. I'll show you some of the competitors just to get the juices flowing, I guess. But this is helpful summary. I showed it in the previous deck, so I won't go back over it today. So just know that okay, just quick review. Smart Start, Category 1. That means lower speed, lower cost, simple interface options. This is our lowest cost play here. So this is our cost competitive one. They're all cost competitive, but this is, you know what I'm trying to say, the cheapest one, put it that way. The Smart Flex, more options, interfaces, PoE is key here, Class 1 Div 2. I don't list that here, but that's an important characteristic of the Smart Flex. The 3241, highest speed, and I have that same stupid mistype here, so sorry. Same, high speed, optional Wi-Fi and GPS, and then, sorry, let me pause real quick. Yeah, a list of countries that the LTE products are homologated, and that's from Oscar. Yeah, Oscar, how should I put that? I do. I'm going to get to that. Oscar, that's a really good question. Let me get to the global thing later on in this presentation, and we'll talk specifically about different country and region support for these. Okay. Hold on here for a thought, because the ICR 3241 also has FirstNet. I'll talk about that. FirstNet is a dedicated network for first responders that AT&T operates. We'll talk about that. But ICR 3241 is FirstNet certified. It's really important if you're in that niche or you serve that niche. The ICR 3211B, again, lower speed, simple interface set there, but key, it has a super capacitor built in for about 30 seconds of communication in the event of power loss. I'll talk about why that's cool. Well, you can imagine, basically, imagine you're looking at a screen of data and Modbus registers coming in, and all of a sudden it stops. And you don't know, okay, did the router did somebody take the SIM card out? Did the network go down? Did it lose power? With that super cap and the last gasp capability, what happens is when you pull power, the router knows to send a save report file, excuse me, send a, hey, I just lost power, come check on me kind of message, okay? So that's very helpful for remote troubleshooting. All right, let me, okay, cool. All right, so when I talked about the family earlier, I said, hey, this all uses the same software architecture and web interface and so forth. And they have more benefits and features in common. And I want to articulate some of these if I can. So dual SIM, multi-carrier support. This is actually, I'm not going to read through the slide, but I am going to spend a few minutes on this slide in particular. And feel free to ask questions, because this is some of the meat of our differentiation and our value proposition. Okay, dual SIM multi-carrier, what does that mean? Well, it means it always uses the best available carrier. So like imagine if your phone, like I use Verizon, let's say the Verizon network was bad in this area, I could just push a button and switch to AT&T. That's a little bit oversimplified for what you do here. You have to like pre-configure what you know you want to switch to. But these support, you don't have to have an AT&T version. You don't have to have a Verizon version. You can put 2 SIM cards in and it'll switch back and forth between those, the SIM carriers. Okay, license-free enterprise routing, 3-year warranty. So what are we talking about here? I'm talking about cost of ownership. So in many opportunities, we compete against much higher priced, more, I don't know, fancy sounding competitors like Cisco, who have a bunch of, advanced routing protocols that we support too, by the way. But unlike Cisco and others, we don't charge an annual software license fee. Okay, so also when I talk about our web access VPN software, we charge, frankly, a pretty nominal rate for that. It's pennies on the dollar or dimes on the dollar compared to what competitors charge. But that's the software we developed and we sell it one time, and you can upgrade it as you go. But for the core routing software on the device, that's paid for once. That's very cool. This app store, okay, router apps. So there are it's less than 100, but tons of pre-configured, pre-written scripts that expand the function, not just scripts, but code that expands the functionality of these devices. So there's apps for Modbus, apps for Node-RED, apps to do Python, apps for Azure, apps for all kinds of different industrial protocols. Very, very, very cool feature here. Excuse me. It's Linux-based, so customers can not only use our app store, but they can write their own apps. This is not a PC, right? So it's a little, I don't want people to think like, oh, I can just, no matter what, I'll just have a bunch of code. I can just throw my code on there. It's not going to have like multiple gigabytes of storage, but for I think it's like 800 megs, might be, yeah, I'll show you speculate. It's either 512 or 838 megabytes specifically for your code on the ICR, and a little less than that on the others. Okay, remote access. So, I'll talk about this in detail. This is actually the next presentation on kind of the remote software. I'll get into that in detail. At this stage, just know that, yeah, that's the next session. At this stage, just know that we don't just sell a modem, right, or some router. We sell really a solution, and you'll have heard Advantech's the phrase SRP, solution ready package. These devices combined with our VPN software is an SRP, right? It's ready to go. And then for just kind of as an aside here, we test and specify a series of accessories, antennas, power supplies, mounting solutions. So this is a great way to just, you're adding dollars to those quotes. You're helping customers provide, by providing something that otherwise they would have to go to some third party and find an antenna on, antennas.com or something. This way, that you're able to capture that business. Okay, product profile. So let's talk about these in some specifics. I'm tempted to go over this a little bit faster, but I would really encourage you to stick with me here, and because what we're doing is kind of like front-end loading. So we're doing a lot of information up front, and then when you see this out in the field later, you'll remember it. So after this session, by the way, we'll take a 5-minute break. And we'll come back and talk about software. I want to, there's only so much that you can take in your brain at one time, right? So I know we're not going to sit here for 2 hours straight and you'll remember it. We have to kind of break it up a little bit. So to that end, good question. Yep, yes. So the question about how would this work in LATAM? Johnny, I see your question there. Yes, will in Mexico and some other areas, but just hang on to that question about the countries for just a second. So thanks for that. Okay, in the US, this is LTE Cat 1, so I should change this. And you guys get to see real-time editing. This is action, like an action training here. Sorry about that. Okay, so Smart Start, as I said, this is the lowest cost platform, LTE platform that we have. Sometimes you'll compete against a company that makes just a customer will be looking at, a module or some super low cost little USB LTE modem. This is really our chance to get down, in the mid to low 200s in this product price wise. LTE Cat 1 is basically 10 megabytes down, 5 megabytes up. Simple binary input output, Ethernet, RS-232, and optional Wi-Fi. Okay, so this is your applications are, for our audience today, you'd be thinking about those applications where the customer says, all I need is LTE, all I need is a network connection. Okay, cool, we can do this. So here's an example of just a simple, this, if you would open this panel in the left-hand corner, you would see the Smart Start, a little PLC, really a data acquisition computer here, and then the connection from the Restream. This customer's in this case, what they're doing is they're collecting data about the basically the chemical byproducts of that oil field, production site. So when, fracking is, or in this case, just pump jack, but when hydrocarbons are removed from the earth, a lot of other things can come with it and be created during that process. So these guys are analyzing data to indicate the production of dangerous byproducts. Okay, so again, operation on all carriers. It doesn't matter. They don't have to go out and check, well, does pump site number 7 have AT&T or Verizon? They just use both SIM cards and maybe have one on a backup plan, right? And then they know, okay, I'm always going to have LTE connection. So slick solution there with the Smart Start. Okay, Smart Flex. The Smart Flex in the US is Cat 3 only. That's much, much faster than Cat 1, 10 times faster, let's say, basically. This has, in terms of hosting applications, this can be a good fit because you've got the expanded, data storage capability in the SD card and in the CPU. Broader set of power input options. Let's talk about power for a second. So flexibility in terms of power means 12, 24, 48 volt power and PoE, right? Both power device or power supplying equipment, PSE. So very flexible in terms of power. In terms of physical interface ports, up to 5 Ethernet ports, or 3 Ethernet and 1, and then serial, or 2 Ethernet and serial. So RS-422, for example. So really, really flexible device. If I was a partner in the automation space, I'd want to know about this. This is designed. It fits really slick into a cabinet on a DIN rail. The PO. The thing about the switch option means you can replace a switch potentially. If you're designing a cabinet, you don't have to have a separate, another switch there. GPS, Wi-Fi. This is a very, very cool product. As a use case for this, you think about earlier, right when I said machines, remote machines, and I gave a bunch of examples. Here's another example where the machine is an industrial boiler system. Okay, so think about in a hotel or a hospital, some kind of campus setting. You've got a boiler system, and this company, Hamilton Engineering, monitors that boiler system. And what they did is they wrote a user module. I think we helped them do this, but they wrote a user module. Remember, I said they were our app store, if you will, and they to present the data in a custom way, and you see that in the image there on the left. So that's their customized dashboard. but they've got these specifically alarms for when something is going wrong, or the conditions are such that something is about to go wrong. Okay, so perfect case for the SmartFlex there. Okay, the ICR3241 is the newest, I guess, latest and greatest as far as our LTE lineup goes. As I said, this is both the fastest and the slowest. So there's an LTE Cat 4 option. That's the 3241. There's an LTE Cat M1 option. That's the ICR 3211. There's so much overlap besides that. I just wanted I think we can, what you'll find is that the Cat M1, the 3211, works for a lot of Modbus polling and data acquisition applications. The Cat 4 is as high speed, camera connectivity or FirstNet. Let me explain. Actually, do I? Yeah, I'll talk about FirstNet on the next slide. All right. So as with all of our routers, it's got the 2 SIM slots, but it also has an slot for an eSIM, an embedded SIM. Okay. So you may hear about that. I'm starting to see it on RFPs occasionally. All that means is that a SIM can be installed at the factory. Okay, so you just power the device up and it's ready to go. You don't have that loss of, or that risk of SIM theft, which actually happens, and you can streamline the installation process with that eSIM. Okay, latest and greatest Wi-Fi, just kind of our standard interface set, and the key thing here is lots of storage, right? So more computing horsepower for custom applications like those user modules that we were talking about. All right, so you've seen that FirstNet logo there, and this is unique to North America, so I know we have some folks from Latin America that are joining, but in the US specifically, we have a dedicated first responder network that's called FirstNet. It uses the AT&T radio network, so it's basically the way going back to this analogy here, it's a dedicated lane for first responders, okay? That's not just police, fire, EMS. There are also, utilities can use this, water, wastewater, medical can use FirstNet. The ICR 3241 has gone through all of the, performance, reliability, especially security certifications. So it's ready to go and it's certified on FirstNet. If you service utilities, police, fire, EMS, water, wastewater, you should know about this. This is a really important one. And in this training, because we're covering so much over 2 or 3 hours or whatever it is, I won't be able to spend a lot of time on FirstNet. Just go to firstnet.com, search for the devices, you'll find the ICR there. This is really unique, and we can talk about that offline. Happy to do that. As an example of how that works, and this example is good because it uses FirstNet. It wouldn't necessarily have to, but it does. So in California, we are serving Caltrans, which is their, California Department of Transportation, across several districts. I mean, you can imagine California's got more roads than most countries, frankly. And in this particular application, we're connecting both traffic. This example here is a traffic controller at an intersection or a variable messaging sign connected over SmartFlex, or use the ICR, forget that, just use the ICR here conceptually, over FirstNet to the traffic management center. Right now, if you Google California wildfires, you'll get a ton of reports about what's going on in California. Know that, so why would they have to use FirstNet if it's just like messaging signs? 2 things. One, these are connecting also CCTV cameras and the variable messaging sign. So it's really important when thousands and thousands of people are trying to get out of an area in an efficient way. It's really important to be able to update those signs to say, hey, go this way down the canyon, not that way down the canyon, right? Or whatever, right? So optimizing that traffic flow is critical. as is seeing what's going on in real time on the cameras. And so that's why Caltrans uses Advantech's FirstNet equipment. I'm going to just do a quick check on attendees. You guys are all, this is awesome, man. Okay, you guys are still here. You may be tuned out, but because I can't see you, but I hope this is, hope we're keeping it interesting. A couple notes on this real quick. So I said FirstNet, NEMA TS2, just NEMA is a operating, really in our case, more of an operating temperature compliance. But, you know, we kitted this all up, and our partners certainly would do this, or we can do it. It's a value add that a lot of times partners want to capture, this kitting process to just send the device, the antenna, the power supply all out at once, and make that happen. Okay. The next few slides, I'm going to introduce some software that we sell. I want you to know that this software is actually, it's very important. It is, how should I put this? It's hard. Okay, so let me put it this way. It can be kind of hard for customers to do what this software does with non-Advantech software. In other words, it's uniquely designed to expand the value and functionality of Advantech routers. And so customers just need to be aware that this is pretty helpful. Just a second. Okay, so when you're dealing with customers who are using or evaluating router software or LTE routers, they're going to ask, and I know from some of you that are on the phone, you guys, we've dealt with customers with these challenges. How do I update the firmware? How do I, or they'll say, well, I want how do I change the configuration? Or I want a secure connection, but I don't want to pay more for it to my LTE carrier and be tied to them. Or hey, I have my own cloud application. I just want to pull data from your router with APIs. These are super common pain points, and you can imagine it, right? If you were in the position of a customer who's installing these, there are essentially two options. Right now I'm going to focus more on web access VPN. There's a reason for that. Web access DMP is going through a couple changes, fairly significant changes, still available. Really great for when a customer says, I have my own application, I just want to pull data from the router. This is great, okay? The reason I'm focusing on web access VPN is for this audience, for the audience that we have today, and generally within the IoT group at Advantech, web access VPN is just, it's perfect, okay? So when you have a machine builder, like I said, there's a remote machine application who wants to connect to their device, and they want to set up a network of connected devices, and they want to do that without being tied to one carrier and in a cost-effective way, web access VPN is just a perfect solution for that. Let me focus on this right now. While we're doing, so having just introduced that, know that the next session that we're going to do after a bio break here in about 5 minutes, we'll talk about this software. And I'll focus in that session, I'll focus on web access VPN. Okay. Before we end the LTE section, though, we have to address competitive positioning, because this market, whether you're in Canada or North America or Latin America, there are a lot of competitors out there. The Latin American colleagues on the phone, you guys deal with low-cost competition from Teltonica, from Robustel, from InHand. In North America, and some with E1. In North America, I want to talk about Cradlepoint and E1. Okay, Cradlepoint is, and the reason I'm choosing these two is because they tend to be representative of two categories of competitor. Cradlepoint represents the how should I put this? Kind of the almost, I don't want to say consumer, that's not fair, but almost the more like retail, light industrial, more likely to provide Wi-Fi access to human users. And EWAN is more in this industrial protocol support and industrial networking space. Let's just call it that. Okay. At a very high level, and again, I'm knowing that there are people from different regions on the phone, but let me just at a high level. Cradlepoint, this is how I position us against Cradlepoint. They are an expensive retail-based solution, okay? So you pay for the enterprise software, you pay for the higher hardware cost, and really, at the end of the day, most of their business is retail branch network backup, okay? Well, if you're talking to industrial system engineer, that's not real compelling, right? You're not really talking their language if you're talking about point of sale systems. Whereas Advantech, competitively priced, both software-wise, hardware-wise, and actually industrial, right? So talk about Modbus TCP and all kinds of different industrial protocol support, and our backing as the #1 industrial PC brand in the world. So this is us in a snapshot. That's against Cradlepoint. How about EWAN? Okay, so EWAN, a lot of our partners either know EWAN or compete, maybe even carry EWAN. Now that Advantech has this web access VPN solution, okay, we have an extremely competitive solution against EWAN. Specifically, EWAN's, they're what they call talk to M, okay? So EWAN's pitch is, so EWAN is a European-based company. They've done some business in the US. They're very niche-y, if you will, very focused on remote PLC connectivity over cellular. And at the end of the day, these guys only have, there's a few things I want to call out here. Their routers are more expensive and they only work on AT&T. That's a major, major shortcoming. Their VPN solution, it's free if you don't want to do very much with it or use a lot of data. And if you do, you need to pay for it, okay? So $1,400, again, they're using just a 50 device example here. You can just do a little bit of math and see how dramatically less expensive we are. And ours is customer hosted, right? So we don't own the data, we don't manage it, we don't pass it through our servers. This is Advantech solution is all when a customer wants their data on their servers and they don't want to pay an arm and a leg for it. That's where our web access VPN really shines against EWAN. Okay, so I think it was Zach asked about some upcoming tech, 5G in particular. Real quickly, you will hear about private LTE every now and then. Private LTE, LTE band 48, CBRS. This is unique to the United States. This is fairly new. There are maybe less than a dozen real use cases for this at enterprise level across the US. If you do come across and the customer is interested in private LTE, AKA band 48, let us know. We were just talking to someone yesterday who's interested in a large customer. You will start to see it on our path to 5G. We do have some prototypes for this. We've done some testing with very large customers. Testing it out. This is like just to explain what it sounds like. You create this customer has a line or a giant manufacturing site, let's say, and then for security latency with the major requirements. You definitely, and it's unavoidable. my Zoom window was spinning there for a second, but hopefully I still got you. All right, just a second. Okay, I'll go back to sharing screen. Sorry guys, I think I lost the screen sharing there for some reason. And I just want to make sure I'm recording. Okay, cool. Sorry about that. I don't know what happened. I heard yesterday for some reason, so I don't know. Okay. Okay, I'm just going to do a quick kind of an audio test here. I will talk more slowly, but hopefully you can still hear me. If you're having trouble with audio, please chat back in. Shoot. Okay. 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 I'm gonna check back in here, guys. I think I'm back on audio. Can you hear me now? Right. You gotta love technology. But it is actually pretty cool, right? We've got people from all over the North and South America on this call. So we love it and we hate it. So all right, we'll keep going. Okay. So as I was saying here, so recording, screen sharing. Okay, we're good. As I was saying, when you start talking about LTE, you'll get SL 5G. What we have to do is help customers break down the monolithic view of 5G into the specific use cases. What I mean by that is 5G isn't just about faster Netflix or TikTok videos or whatever. 5G is about either, let's start on the bottom here, okay, because there's three specific use cases. Let's start with what's available today. Massive or mobile IoT. Remember I was showing you NB-IoT, LTE Cat-M. The value here is low power, low cost, remote sensing example, and that's available now, okay? So yeah, we have 5G now, okay, at least this use case, all right? What you see now on you can buy 5G phones or 5G set-top home Wi-Fi hotspots, enhanced mobile broadband, so really fast internet through 5G. Okay, that's coming. And I'll show you our product roadmap for that, or the product we're designing for that use case. Even further out is this critical communication. So you see, I don't know, I forget if Zach's question about CV2X and 5G. You see critical communication, so ultra low latency. You read about 5G being used for smart cars or remote surgeries or whatever. That's critical communication. That's a ways out there. That requires a pretty massive network build out.
that's several years away. Okay, massive, machine type IoT available today, Cat-M. High-speed mobile broadband, enhanced mobile broadband use case coming soon. Critical communication, ultra-low latency, further away. All right. Here's a kind of another way to look at this. I don't want to get super into this, just to know this, all right? So there is something called LTE Advanced, LTE Advanced Pro. This is like using the existing LTE, kind of standard LTE radio technology, but just making it really high speed. This is cool. We don't have product in this case. It's like super high speed. But at the end of the day, most of our industrial applications don't really need this type of technology. You're starting to see early 5G non-standalone. That means it requires fallback to LTE. Okay, this is a top. So you can pay. I was looking at this. I think if I want to upgrade my current Verizon Samsung device to a 5G device, I'll be paying like a 50% premium. And in exchange for that, I get really fast internet in some places. So if I'm in a 5G, it's basically like a 5G hotspot area, 5G. Cool for marketing, not really cool for your real industrial solution at scale. 5G standalone, again, this doesn't require fallback to LTE, but it's still not quite there for what we're envisioning. When you get to 5G standalone and think about like mid 2021, late 2021, this is full 5G. Okay, that's bringing kind of really all the hype is really coming at that. It's really coming to fruition, I guess, at that stage. There is about this show. There are a lot of new terms involved in 5G. So 5G standalone, non-standalone, 5G. This is the true kind of 5G standard. So what we're designing. Oh, and by the way, as you'll see on the next slide, there's a lot of antenna ports. So like, why is that? Well, 5G uses, for true high speed, uses millimeter wave technology, I guess, and that requires a lot of antennas. Here's what I mean. So as a summary, 5G marketing is probably a year ahead of reality at least. Can I upgrade a device? This is a common question. Can I upgrade from 4G to 5G? No, you will see people marketing that. It's not realistic. The most responsible answer is no, okay? Both because you need more computing horsepower, you need more antennas, it's just not, it's not a reality. Again, when people ask about 5G, help them to evaluate it through the lens of not just one picture of 5G, but the three different use cases: machine type IoT, enhanced mobile broadband, and then critical communication. However, it's always kind of nice to just show that yes, we are building a 5G device, and so this is our ICR 4000 platform. Super high speed, and because there are applications, specifically onboard vehicle networking, or applications that require a lot more how should I put it, like computing horsepower, Docker containers and others. And then for networking applications, for CCTVs, for backing up fiber connections, this is very common in traffic applications. Traffic control application. So this is just kind of a picture of our ICR 4000. It's coming late Q1 2021. All right, I have a couple questions about geographic coverage. Okay, so here's the thing. There are what, 200 plus or minus 10%? There's hundreds of countries in the world. So for us to have a list of our, 4 different hardware platforms by 200 countries, and that each country is continually developing, the carriers in each country are continually developing new stuff, it's not really helpful. Luckily, Luckily, there tends to be a pattern across regions for what LTE bands are used. So you don't have to worry about this when you use Wi-Fi, right? Your Wi-Fi laptop works just as well in Chicago as it does in Sydney. It doesn't matter. But for LTE, there are some unique characteristics. Let me just say a couple things here real quickly. Advantech has the most comprehensive set of routers, the most comprehensive set of routing solutions for geographic installation in the world. Okay, so no one is better at this than us. So whether you're in China, and the reason for this is Advantech's a pretty massive global company, and we do business all over the world. So what that means is, in China, you need to get CCC certification. Okay, we did that. In Australia, you need to get Telstra certification. Okay, we did that. In South Korea, you just keep going down the list. In Latin America, some of the customers were from Latin America. Specifically in Colombia, you need to support band 4 and band 7. Okay, we did that. I do have a list I'll send you my most recent list, and I saw who the question came from. I will send that out. But what's most important is to know if you're going into North America, here are your options, Latin America, and you can look, right? We can specify, okay, if this is going into Chile, we know we need to support these certain bands. And the data sheets list it. We can pull up the information online. This ICR 4000, by the way, will work in all of these regions. It'll be a kind of a global router, but it's not going to be cheap, and so it may still make a lot of sense to know that, like let's use this as an example. You've got a machine builder in Chicago who wants to install, who builds pallet wrapping machines, packaging equipment, and he sends them to Europe and Asia. Okay, cool. And the US, of course. So in the US, and he likes the ICR series. Awesome. In the US, you use the ICR 3241. In Europe, you use the 3231. And in Asia, you really use the 3231 as well. In Australia and Latin America, you use the 3232. Not super complex, but I just want to explain. This is something that's kind of unique to LTE technology, okay? All right, I mentioned accessories earlier in this presentation, just to give you an idea, tons of different antenna options. LTE, with the exception of Cat-M, all other LTE technologies require 2 LTE antennas. So some of those that can be combined in one dome, or they can just be screwed right onto the terminal mounts of the device. Power options are PoE, and then you see some of the mounting solutions. So again, just to give you an idea of what we've got on the LTE accessories. Okay, we've been going for about an hour and a half now. Holy cow! Let's take a break. It's 2:27 Central right now. I'm going to I'll keep this slide up. 2:27 at 2:32 Central Time. I'm going to start back up, and we'll go over device management software, and then we'll get into LoRaWAN, and we'll see how the time goes. Okay. So let's just to make it easy. Let's just say 2:35 Central Time. 2:35 Central Time. Come on back. I'll put up a slide here that says that. So I'll go on mute. I'll talk to you guys back in about 8 minutes. Okay. Okay, we are back. It's 2:35 Central. And we're going to talk about device management software here. So let me share my screen. Okay, and we're off to the races. All right, quick audio check. Somebody want to just chat me and can you hear me? And we will move forward. Testing, testing. All right, thanks, Nolan. All right, cool. We are off to the races. Okay, up to this point, we have covered all of the kind of an overview session where we talked about all of the wireless IoT products at Advantech. Then we talked specifically about the LTE routers. Now we're going to talk about this value-add software. So software for some of us is we maybe tend to think of ourselves as hardware people. We know that software is crucial though, right? And so what Advantech's done is develop software, value-add software that is really, I'll talk about why this is so important. Okay, so this is especially relevant during COVID, right? I don't know if you guys remember a movie 10 years ago or so, The Love in the Time of Cholera. I think about this as remote access in the time of COVID-19, right? So getting remote access to machines on customer sites has probably never been more important, because you know that your ability to access customers, go into in-person meetings, go into the shop floor, whatever, that's extremely limited now, right? So this remote access is extremely, extremely timely, okay? Instead of just focusing on the software, I want to talk through some qualifying questions, and we'll do some competitive positioning too, okay? Because that's, as I said earlier, I really want our partners to be able to hone in on selling the LTE routers. So this is going to really strengthen your skill set in this around this. I will skip through this. I just said, we reviewed this, the fast lane, the SIM cards, some that don't use SIM cards. All right, but this, I will say, these are the products that use web access, that use the software, okay, the routers. Specifically these, we just did a session on this. I won't review it, but the low cost, flexible, fast FirstNet, and then CAT-M on the ICR, going from left to right. Okay, how about some qualifying questions here? So you're all salespeople, different degrees of technical, training and aptitude and so forth. But at the end of the day, we have to be able to ask good questions with customers. Man, I tell you, if I could get folks to ask one question consistently when they're talking to customers, like, okay, how are you connecting to the internet? There's probably two wireless answers to that, right? LTE or Wi-Fi. Now, let me just check this. Hi, John. Yeah, I'll get to that. I'll get to your question about RCNet. Yeah, that's good. That's good. I'll talk about that. So if you're talking to a customer, maybe it's about a PC application, right? An embedded type of application or a touch, panel PC, whatever it is. They're connecting to the internet somehow, right? They are. The web application is on the web, so they have to connect to that. Ask how they're connecting to the internet. If it's LTE, okay, are they using an embedded module or a dedicated, router, modem? Some people call them modems. It doesn't matter. Modem, gateway, router. What speeds are required? Is it high speed, high bandwidth? If it's Wi-Fi, hey man, our ECI series is a slick Wi-Fi access point. The routers can also be Wi-Fi access points or clients and give some LTE as backup. That's a really slick way to do that too. But how are you connecting to the internet? Okay, if someone's using an embedded LTE module, hey, this is like, hey, I'm going to build my own solution, right? Hey, thanks, I don't need your product. I'm going to build my own using a pre-certified LTE module. This is a common question, and it's worth answering this. So can I use a pre-certified LTE module? Yes, that's what we do, right? Advantech, I should say Advantech there, this is DB Advantech. So yes, you can do that. That's what we do. But you still have to certify it as an end device, okay? So our devices go through this end device certification by Verizon and AT&T, T-Mobile. That's like your phone or a router, they're end devices. Within that end device, there's an embedded module. okay? So that's fine to use a pre-certified module, but you still have to certify it as an end device. If a customer, insists on using a pre-certified module, it's okay. There's a lot of things involved in that, though. So this is a table to help customers understand costs and timing involved with building their own LTE device. The point is, it's expensive and time consuming, and you're probably not going to be successful the first time around. You may end up hiring a engineering consulting group to help you get through it. And it's just painful. Okay, so the point here is, yeah, look, use a certified end device, at least for time to market, okay? If you are using a pre-certified module, you still have to, design your own end device in addition to certifying it. To be certified, you have to write and support firmware that provides for command channel access, for remote, over-the-air firmware updates, increasing data connection retrace. So this is basically like, you still have to have a device that's going to play well with others on the LTE network. Okay, so this is complex stuff that most people don't. Anybody can learn anything, but most people don't have this support organically in their wheelhouse or in their engineering group. Okay, the speed question. So what kind of speed do you need? If I'm talking to a customer who's interested in LTE, I want to know, okay, are they looking to connect? Are they looking to do like a team viewer session with a remote PC or PLC? In that case, probably SmartFlex or ICR for that higher speed. If not, if I'm just doing data queries and pulling a Modbus register, I'm looking at the Smart Start or the ICR probably. Okay, these are kind of the use cases and the speeds and the relevant use cases for those speeds. Okay, that's just a couple qualifying questions. Let's talk again. I said we're going to focus on web access VPN. I showed you these pain points, these questions. That's certainly relevant still for this. And I showed this slide as well. Let's get into the meat. Let's go to web access VPN. All right. What is it? How does it compete? How is it sold? Web access VPN it's a software package that is installed on premise or on AWS that machine builders use to remotely and securely access their machines. Okay, so it is software. You pay a license fee. I'll talk about how that works later. It's sold in different size tiers depending on how many remote routers you want to connect to, and it's hosted on AWS or on a customer's, their own virtual machine. The ideal target here is people who are building industrial equipment and they need access to that industrial equipment remotely. Remotely means remotely, no more flying around. You'd be surprised, and maybe some of you have done this, visiting remote sites because, connection's down, or I want to update the PLC and I need to go there to install it, install the update. And then securely, so this does establish a VPN connection. There's a couple competitors. Let's focus on EWAN. But one of the other competitors, frankly, is the carrier's own private LTE option. We support private LTE. This is not something hard for us, but it's a solution that comes from the carrier. So a carrier will say, hey, Mr. or Miss Customer, I'll sell you a dedicated SIM set that will only go on our network, on the Verizon network. It'll never touch the public internet. And that's, I guess, sort of true. We can debate, how true that is. But the important thing is when customers use this option, the private option from a carrier, they pay for it. It's not cheap. And then they're only able to use it with that carrier. So down the road, they may want to switch carriers for cost reasons. They have to reset their whole private LTE network setup, or they want to switch for coverage reasons. Same thing. So the private LTE from a carrier ties them to that carrier. The other competition, EWAN. So EWAN routers are more expensive and only support AT&T. Major drawbacks. some specific talking points with E1. Again, if you haven't seen E1 in the marketplace, that's okay. You probably will. Even if you don't, it's worth it to know just how we're different and what makes us unique. So this is all either cloud hosted or enterprise hosted. In other words, on a customer's premise. E1 is only cloud hosted. What that means is that the customer has ownership of this. Okay, and that's important. That this is a customer thing, and they pay for it. They own it. Advantech's Web Access VPN offers full, user permissions, setting up pools, grouping of routers. With E1, you pay for that. And the reality is, look, any enterprise user is going to require different permission levels and the ability to group, by, routers by customer, let's say. That's just kind of a no-brainer. Our monthly data, look, it's not, I mean, in the case of Web Access VPN that's hosted on AWS, you're paying some AWS hosting fee or, data rate, but it's very cheap, frankly. With Talk to M, you get a limited amount of data for free. And then the Pro version, you get more, but you're still paying for it, okay? So there's a risk here if you're using E1 for surcharges over when you get data overage. How many VPN connections? We support 5 concurrent VPN sessions, so 5 different users can dial in or VPN in to that appliance. That's not possible with Talk to M. The reality is most applications are going to require some kind of concurrent connection, right? It's just, think about troubleshooting with your IT, your remote IT people on your own laptop. I mean, you have to have concurrent sessions. Web Access VPN is set up for longer term use. So you pay once to get 10 years worth of productivity or, functionality. The first 2 years are included in that cost. And then after that, you can upgrade, 2 years at a time if you want to continue getting upgrades. Talk to M is always just a 1-year term. So that means lower total cost of ownership for us, all right? The cost for us is again, 5 devices are free. You can test it with 5 devices. You can then pay in 5, 50, or 5,000 device tiers. You're basically paying $28 per device for 10 years. That's crazy, crazy inexpensive. So the point here is this is very simple and compelling pricing, all right? Okay, so those are some differences to E1. Let's just talk about what the options are for a customer who's installing remote LTE equipment. And please do chat in questions here. I think we have some good interaction here. Okay, so I'm a customer and I am installing remote LTE routers on my customer sites, and I want to be able to access them, all right? So there's a few ways to do that. Going from left to right here, you can have essentially a private but dynamic IP, and I will just fix that typo here while we're at it. Real time. Oops. Anyway, you get the idea. Okay, so you can this method. It really relies on the remote router to initiate the connection, and then the web server can respond to it. Not encrypted, not particularly secure, not user-friendly, no firewall. I mean, so this is really, people don't use this. A public dynamic or static IP here, you're open to man-in-the-middle attacks, very, very insecure, very rarely used. The 3 on the right are what we actually see mostly in the field, okay? So this in the very middle, this private APN option, this is what I was referring to in that the private networking offer from carriers, okay? So in this example, the customer buys a private APN solution from a carrier. They're tied to the carrier, all right? Frankly, it's not particularly easy to use. The data is not really encrypted or authenticated. It's just on the private APN, so there's vulnerability there. And again, they're tied to a specific carrier. what some customers will do is have their own VPN server, okay, so like a VPN concentrator, making a VPN connection to the router. We certainly support, by the way, we support all of these, but we support this, no problem. And if you have a VPN, if you're used to managing VPN networks and you have the IT group to support it, this is fine. It's a little cumbersome. So in this case, let's say you have 100 devices out there and you want to add device number 101. This requires, rebuilding the routing tables and setting it up again, and it can be a little cumbersome. So because of some of these weaknesses, that's why we've developed Web Access VPN, all right? So Web Access VPN, with Web Access VPN, all the data is encrypted and authenticated. It's independent of the carriers. You don't have exposure to unwanted traffic, very high security, very user-friendly, and the centrally defined topology makes it super secure and easy to use, okay? So here's how it works. It's really simplified, but just bear with me here. So this Web Access VPN is, you get a piece of software from Advantech, and you can go, I'll show you the link, you can go get it today and either run it on AWS or, on essentially an AWS server or on your own machine on premise. These devices then have an app on them. Remember I was talking about the app store? There's a Web Access VPN app that's installed on the routers, and they're configured to talk to the Web Access VPN server when they come online, okay? So, the software and the VPN server establish this VPN encrypted tunnel, and they're talking securely to the server. And you can imagine off to the, I'm using my mouse here, but you can imagine off to the right, the actual production software, whatever that might be, using this VPN server as the path to the remote routers. So what's really cool about this is you've got a fixed IP address, and you can talk to the other devices on that network. So when this is set up, you configure, each device it can be on separate LANs, but they can talk to each other with a static IP address. So you, from your Web Access VPN server, can remotely access the web UI of that remote device. But not only that remote device, all the devices, I just want to show this, all the devices behind that device, right? So these LAN IP addresses are translated virtually, so you're NATing directly from the VPN server to the remote PLCs, remote desktops, whatever it might be, cameras, doesn't matter. The firewall rules can be set up either as like a network firewall or a device level firewall, all right? So devices can only allow access from certain devices or from certain network ports. And it's also can be used to connect any other non-router device that's on the network through OpenVPN. So this is not just Advantech devices. This also supports non-Advantech devices that, as long as they operate on OpenVPN. So again, the point here for Web Access VPN is central. It's a central point for online remote access directly to the router GUI and to connected devices, all right? So to be able to do this is really, the idea of being in one part of the world and dialing in I say dialing in, but remotely connecting to via a static IP address to that remote router is so powerful. And that's what we offer. And you can imagine there's obviously more applications than this, but some great, connecting to devices for predictive analysis, OEE. I've got a bunch of decentralized facilities. I need to talk to routers at those facilities. SCADA applications are great for this, where I've got a number of different remote devices that on different customer types, different types of customer sites. So I'm trying to think one of the key value points here, and I don't have a great slide for this, so let me just articulate this. Suppose you're a reseller of Advantech. You're an Advantech, value-added reseller or system integrator, distributor. and you sell to a bunch of customers, you can offer this as your own value-added like network management service, okay? So you can set this up so that each customer has their own, basically their own network, okay? And you can give them their own access to that network. And then within that network, they can group devices per their own customer site. It's kind of hard to explain or visualize, but I think you'll understand what I'm saying, thinking about the reality that customers have different sites, and they don't necessarily want a device from one site to be able to talk to a device from another site. We can support that. Okay, how to get started. You can get the free version. It's on Amazon Marketplace. You can get the link from us on these pages here. And again, I'll share this. Very helpful videos, very helpful how-to articles. It's you try to make this as easy as possible. Okay, how does it work? How's it priced? As I said before, there are 3 different tiers, and these depend on how many devices you have. So devices here means, you know, remote device, Advantech router, let's say. Clients means, you know, the computers that are accessing those devices. You see the size tiers, 50, 500, 5,000. When you pay, you know, $1,437 for this part number, this 50 device part number, you get 10 years of functionality, okay? In the first 2 years of that 10-year term, upgrades, patches, all that is included. And after 2 years, you may say, okay, well, it's working fine, I don't need anything, and keep going for another 8 years. If you want to continue those 2-year upgrades, you pay a pretty nominal fee down here. You can see that per tier. If you want to go from 50 to 500, there's a price, 5,000 to 5,000, there's a price, and so forth. So these are just, again, just kind of explaining how this works. Hopefully this makes sense. It may be a little confusing, but once you think about it, it kind of sinks in. So, all right, we went through that one at a pretty good clip. We're right at the 2-hour mark, and actually this is perfect because we're going to get into our wireless sensing next. So let me do this. Let me do, I will go through LAN and industrial Wi-Fi. So I'll go through session 4 and session 5. We will take another brief 5-minute or so break after session 5, and then we'll close out with some fun customer stories to entertain and also give you some ideas of where this stuff is used. Okay. So let's go to LoRaWAN. Feel free to chat at any questions on what I was just talking about. Going through it kind of quickly, but hopefully it's making sense. All right. We are off to the races. Good. All right. Well, stay with me here. All right. Sharing screen. Audio is good. Chat any questions, or if the audio breaks down, let me know like it did before there. Okay. LoRaWAN. Earlier in the slides, I introduced earlier in the training here, I introduced LoRaWAN as an interoperable standard for long-range, low-power communication, specifically for sensing over 900 megahertz frequency. So we'll do a little bit deeper dive into the technology, and then we'll talk about our products that are LoRaWAN capable, and we'll talk through some use cases as well. So LoRaWAN, again, we said there's 2 categories. LoRaWAN does not require a SIM. All right, so LoRaWAN is on this bike path, right? It's on the not on the highway. No SIM. LoRaWAN is a licensed standard over here on this bike path that is paid off in these products here. And so these are the products we'll be talking about. It's long range, all right? So that's a really important thing about LoRa, and it's low power and it's secure. You're not going to be doing control messages with this. You're doing sensing and data acquisition, all right? Okay, we'll talk about the technology here. So if you are to Google LoRaWAN, you you could get confused, unfortunately, because well, because it can be confusing. Let me just make it really, really clear. You'll hear about LoRa, okay, L-O-R-A. LoRa is the physical layer, all right? LoRaWAN is the interoperable standard that's built on top of that physical layer, all right? So LoRa is just the band, okay, the ISM band by region. For our case, in the U.S. and Latin America, we're all in the 915, so that's fine. That's us here, 915. Modulation, okay, so the physical layer, the radio link, okay. On top of that, there are device behavior, device classes, MAC addressing, security, all that stuff. That's all built on top of LoRa. So LoRaWAN is what we support, right? And that's what matters in the market. Why do I bring this up? I bring it up because there are some products that use just the LoRa, and then they're not LoRaWAN, so they don't follow a standard above the physical layer. Don't worry about that. You probably won't run into it, but if you do, I just want to explain that. So LoRaWAN, it's our standard. All right. In LoRaWAN, there's the other thing. Let me make clear. Yes, sorry. I really don't want to confuse you, but okay. The first distinction we made is between LoRa and LoRaWAN. The second distinction we need to make is between public LoRaWAN and private LoRaWAN. What's the difference? Okay. In any application, what's the best way to put this? I tell you what. Think of it this way: for what we're talking about, all the key Advantech use cases are for private LoRaWAN instances. What that means is that the data is being collected from a node to a gateway and then some kind of IP connection to the internet, and then from there the web services are accessing that data. There is an option to use what's called a public LoRaWAN network out there. So there's vendors like MachineQ, the Things Network, Senet, S-E-N-E-T, there's maybe half a dozen globally, and I apologize, I'm not remembering all of them. But what they've done is they've set up a public LoRaWAN network, just like Verizon has a public LTE network. These carriers have public LoRaWAN networks. What's important is that this phrase here, okay, this network server, in a public LoRaWAN network, the LoRaWAN gateway here is not acting as a network server. The network server functionality is being done in the cloud. This may show it a little bit better. The Advantech LoRaWAN network, the Advantech LoRaWAN gateway, the WISE 6610, I'll show that in a second, that has a network server built in, all right? So we're able to go into, this is why this is relevant to a customer. We're able to go, and you're able to go as our partners, onto a customer site, let's say water treatment, let's just use that, or a mine, it doesn't matter. You're able to go onto that customer site and say, okay, Mr. and Ms. Customer, we can set up a LoRaWAN, a private LoRaWAN network here with the end nodes. We'll show those. Remember, those are the WISE 4610 or WISE or 2410 or the BBWSW, those nodes here. We're able to provide the gateway, the WISE 6610. The network server is built in to the gateway, and then those can be sent to your application goes to the server and gets the data for its application. And this is all secured end to end. That gateway is managing and the network server on board managing the encryption and the communication between the different nodes. Okay, a little confusing. Let's just real quickly, I mentioned how LoRaWAN is secure. So both the network session and the application session are encrypted. This makes this pretty darn secure, okay? So the nodes are, the application is verifying that the data is coming from the right place, and that network session encryption is being maintained by the gateway with the network server built in. So hacking this is really pretty hard. Okay. There are different ISM bands for us in North and South America. I should say this is for South America too. This 900 megahertz band is where we're at. If you want to see, you want to talk about link budgets and things like that, you can look at this. But the point is, long range 900 megahertz. Okay, so far so good. We are moving on to the LoRaWAN product offerings here. Let me just make sure I'm not rename myself here. Okay. Make sure I'm not missing any questions. So far, so good. Cool. All right, Advantech LoRaWAN product offerings. Go. Okay, this is a slide I showed before with summarizing our product offerings. The WISE 4000 line. Let me see what the best. Yeah, I'll just leave it here for now. 4610 sensor node to gateway. Opportunity for GPS, solar powered here on the 4610, can be battery powered too. The Wizard form factor has a LoRaWAN option. This can be battery powered as well. Super rugged enclosure, talking to the 6610 gateway, and then the vibration sensor. And as I said before, these can also talk to third-party gateways. So there are gateways from Tektelic, from Multitech that we work with as well. Okay, so this gateway has a few things that are worth mentioning. I said earlier that it's got a network server built in. That's really important. So it's forwarding LoRaWAN packets to the web application. Oh, Actility, that's it. So these are some examples of the public networks, by the way. So this can work on a public network. Actility, Everything Everywhere, Things Network, Senate. These are some common public LoRaWAN networks. But this is a gateway this is when I say point to multi-point, this is the point here, right? This is the gateway that's establishing the connection with all the other LoRaWAN nodes. It's a VPN, so we can actually have a VPN connection to this. Do it using, you can set up Node-RED dashboards for visualizing the data, MQTT data. Ethernet or cellular connection available on this. So that's the gateway. The sensor nodes are as follows. The WISE 4610, I gave a little bit of a highlight to it earlier. Let me pause here and just explain something that's very important. The WISE 4000 product line is designed with interchangeable I/O modules here, okay? So the 4610 is the wireless portion of this. If you look at this little blue section here on the bottom of the device, that's interchangeable with an S672 module, S614 module, and others to provide different interface options. So you as a partner, or as you're explaining this to customers, 4610 is the wireless section. The S6XX part number refers to the physical interface or the physical connection down there, all right? And this connects over LoRaWAN to the gateway. The vibration sensor, the 2410, so it can be magnet mounted. It can screw in with a screw post, like a threaded, post to the motor that it's monitoring. Measures temperature as well. So again, this is an extremely, extremely slick way to monitor pumps, motors, machines out in the field. If you think about it, when a motor is going to go bad, it's going to get hot and it's going to vibrate, right? And so being able to report this data into the ISO standard way is very powerful. The battery, I know there's a question about battery life for the Wizards. This is supports a 2-year battery life with hourly readings. That's so 2 years on the WISE 2410. A little bit more on the 2410. So LoRaWAN, super low power. Like I said, runs on 2 AA batteries, lasts for 2 years. Some onboard computing. So you're reporting data. You're reporting this data. Vibration is kind of its own science. So, and I'm not a kurtosis expert or a vibration and monitoring engineer, but these are the relevant data points for reporting this to know, vibration and with the 3 axes of vibration and the temperature readings. All right, the LoRaWAN version of the Wizard node can be AA battery powered as well. Class 1 Div 2, IP66, magnet mounted, all the good things about the Wizard, and form factor talking back to the gateway. So, picture this: no power inputs required. I stick this on a machine. I connect up a sensor, or connect up an analog. Make an analog sensor connection and provision it, and it's connected and reading. So I think the example I have here, here we go. So here's an example. There's a few examples here. LoRa's used quite a bit in agriculture. I mentioned the cattle tracking application. Note that our LoRaWAN implementation isn't really, not really designed for the location elements of LoRa. You can do tracking with LoRa, but that's not really our target use case. In this example, we're looking at a smart agriculture application, measuring soil temperature, pH, humidity, and soil moisture, essentially, collected through the I/O modules. Remember these I/O modules here on the bottom of the unit, sending over LoRa and being presented through WisePass in this case, and then being visualized in a Grafana dashboard. So this is a very cool application for smart agriculture. I showed this earlier. I won't spend too much time on it, but again, this is just quickly an example of the WISE 2410 doing vibration sensing. This is for machine health for HVAC pumps. Here's another example of the 2410. You can see it it's about the size of a salt shaker, I guess. You can see it here on the CNC machine. And it's, again, this spins. This is the motor, it's spinning. The vibration is being sensed right there at the top of the motor assembly there. And LoRaWAN is key here for this penetration, wireless coverage, and then you can see how it's reporting the data, XYZ data, XYZ velocity, aka vibration, into the monitoring system there. Okay, I would just put this in here so when you get this deck, you can see the 6610 gateways, the 4610. You see this, just the wireless interface, and then the physical interface options here, the 2410 batteries, antennas, and then the Wizard form factor LoRaWAN sensors here, or sensor nodes here. Okay, excuse me. All right, we're making good time here. So we've covered a lot so far. Let's tie off on the industrial Wi-Fi, and then we'll do some stories from the field here. So stand by 1 second. Okay, resume sharing. Yeah, Esteban, I see your question there. Yeah, IP68. I was going to say, I don't even know what IP86 is. Yeah, IP68. Let me think about that. Esteban, for IP68, we would have to do, boy, there might be a switch. We might have an Ethernet switch that's IP68. Certainly these can be put in IP68 enclosures. The Wizard is IP67, the Wizard node's IP67, but not IP68. IP68 is like immersion for a period of time or something like that, right? So it's pretty specialized. IP67 is basically the highest we go. All right. Okay, let's talk Wi-Fi here. I don't have to spend as much time, kind of explaining the Wi-Fi technology, right? We're all pretty familiar with Wi-Fi. So let's just get into some of the product options fairly quickly. So obviously Wi-Fi doesn't require a SIM. We'll talk about Wi-Fi access points, Wi-Fi device servers, and then some IO to Wi-Fi type devices. Again, we're over here on the bike lane. We're not talking about SIM card based stuff at all with Wi-Fi. Obviously, we're talking about Wi-Fi. So typically for us, a good Wi-Fi application is going to be indoor. We do have an outdoor rated ECI Wi-Fi access point, and I'll show that. But typically you're going to be indoor. This isn't like a rugged, like the question about IP68. We are IP50 for the highest Wi-Fi access point. Oops, shoot. I almost kept going without sharing my screen. Man, that would not be good. So anyway, what I was saying, guys, I'm sorry. So we're talking about access points, device servers, and then IO to Wi-Fi. We're over here on the bike path, right? We're not talking about any SIM-based stuff. And then, as I was saying here on this slide, this is mostly indoor, shop floor type thing. 100 meters, that's on the low end. We can do more than that. And then specifically our WISE 4000, and then the EKI product lines. Those are where we're gonna have the most Wi-Fi focus. Okay. Within the iConnectivity solution architecture, these are the devices here, just to see at a quick level. Remember, we talked about our LoRa nodes, we talked about cellular routers, we talked about the LoRa gateways and stuff, right? Here we're talking Wi-Fi access points and clients, all right? I want to just real quickly, there is a difference between, I guess, enterprise Wi-Fi and industrial Wi-Fi. When you're at a coffee shop, or when you're at your office, or the library, or your kid's school setting, whatever, that's probably more like an enterprise Wi-Fi network, right? It's humans are involved day to day in the operating of that network, right? So you've got a Wi-Fi access controllers, cloud platform to track user behavior and security. You're roaming across access points. You don't have any kind of hardened temperature range really, or a lot of it's plastic devices. In an industrial Wi-Fi setting, you're connecting machines, right? So you've got a device, let's say a device that talks Ethernet or serial, and you want to get to that over the Wi-Fi network. It's configured and managed locally as opposed to on a cloud platform. Really best, I mean, it can roam across access points, but it's really designed to get and keep one access point connection. Not really heavy. You're not worried about your industrial machine going on Netflix or downloading a bunch of videos or something. So it's not really heavy on analytics, but it does have this extended temperature range for use in industrial settings. Okay, so that's the key point here for this distinction. We're in this industrial space. Okay. All right. Product offerings. So, actually, this is a good slide to show you this interchangeability aspect of the WISE 4000 product. Earlier, I was trying to explain, not very well, but trying to explain how the physical connector module is interchangeable with the wireless module. So this WISE 4000 and WISE 4220, these are the Wi-Fi capable WISE 4000 products. All right, very, very cool. And I'll show those a little bit more here. And then there's this WISE 4060. This is your I/O to Wi-Fi device. So I've got some I/O data points I want to read over Wi-Fi. These are perfect. So the 4012, and then there are some of these that are LAN based, right? So they're not even Wi-Fi. They're just a good I/O to LAN solution. But typically the 4050 or the 4060 in 4012 series are going to be, depending on the digital input or output that you want. This is the option. This is kind of the selection guide for the WISE 4000 series. Okay. The 4220 is where we get into this range of I'll just show you this picture. It's not the one that's got the red square around it, but up here, this WISE 4220. This is where you get into the interchangeable the physical interface options. So WISE 4220, 802.11bgn, single mode 2.4, externally powered, so not battery powered, 100-meter range, let's call it. And then all of these different I/O options. So for analog input, the different AI and DI or RS-45 inputs. And also, and I want to focus on this for just a second, also this stack light monitoring solution. So I don't have a specific breakout slide for that, so let me just show you the picture up here. So this stack light monitor, you guys know what a stack light is, obviously, on the end of could be a surface mount machine or any kind of industrial machine on a production floor. There'll be a vertical cylindrical light that has, red, green, yellow, maybe blue lights on it to indicate whether the device is operating within limit, within spec or not. So this stack light monitor gets basically attached to that stack light, and then it can be connected directly to the WISE 4220 to basically put that stack light status online. Okay, communicate that online. Okay, so that's the WISE. So I covered off on the WISE here kind of quickly, but then product that's also very important to know about is our EKI or the EKI series of industrial Wi-Fi products. So these are all, and on the top here, you'll see what's typically we think of more of as an access point, okay? They can be used in client mode, but just these are typically used as access points. Gigabit Ethernet, dual band, dual concurrent, PSE support for different, and again, this is different form factors and different, power input ranges and things like that. But IP55, I was wrong, I said IP50 earlier. IP50, let's focus on this EKI, on this top right-hand corner, EKI 6333 AC2G. So dual concurrent, dual band, AC Wi-Fi, gigabit Ethernet, pole mounting and wall mounting. So it comes with a pole mount clip or bracket, I guess. Pretty wide temperature range, pretty good IP rating. This is a very slick product for Wi-Fi access. Oh, the APXN. So John has a good question. You may be familiar with the B&B APXN. Let me just show a picture of that here. Kind of going off script here, but that's okay. Let me pause my sharing. Shoot. This is a good question, John. So let me. I do want to address this because Advantech B&B Legacy has a lot of Wi-Fi products. What John is asking about is it's a model that is an access point or client. It's similar to some of these other options. Probably what's most important about this, let me see if I can share my screen again. Because this is a good question. Share screen. Sure, I can share this. Okay. So the question was, hey, what about this? Where does this fit? It's not. So this is not going to be super competitive access point. It's not going to be as competitive as the ECI 6000. It will be lower cost. It only supports up to 9 Wi-Fi clients, whereas the others will support, 50 or more. But this is certainly a very fine product. It also has this advantage. It's probably a better fit for a client, I think, thinking about the fact that it's got these 2 RS-232 ports. I'm sorry, MEI, so 42245 or 232 serial ports, and then the 1 Ethernet port. So probably a better client than it would be an access point. This one is just a China SKU, the 6232, so don't worry about that. So really between the ECI 1361 and this BB APXN product, these are kind of this client options there. And we'd have to kind of go through it with a little bit finer detail to talk about the differences and the relative trade-offs at the client level. But certainly number of clients supported, temperature range, type of 802.11 supported, those are going to be some trade-offs. This is DIN rail mounted, whereas this is more flat, kind of panel mounted. There's trade-offs there. Okay, some fairly specialized stuff here, but if you deal with any applications that are that are either on rail, rolling stock, commercial rail, or just really in intense vibration environments, these ECI 6033 units with M12 connectors and EN 50155 rating are going to be very valuable to use. So this is something that would be used on. Actually, it's not just rolling stock. It's mining equipment, agricultural, power equipment, things like that. Some of these support options for LTE. That wouldn't work necessarily in the U.S., but in Latin America, you could certainly put an LTE card in there. Dual Wi-Fi, dual concurrent Wi-Fi. So different options here for rolling stock. Okay, John, maybe to get into your question a little more about this ECI Wi-Fi client. So my sense is that this client is going to roam a little bit more efficiently than this BB product, maybe not. But this is selective band, so not dual concurrent band, but it does, do 2.4 or 5G. And so this is when you've got a serial or Ethernet device that you want to get onto a Wi-Fi network. This is what the Wi-Fi client, specifically a Wi-Fi device server, would where that would come in. These are our 2 access points. I'll show you, or I guess 3. Excuse me, 3 access points. Fairly straightforward, cost-optimized way to do selective band Wi-Fi access point setup here, right? So very strong Wi-Fi link budget, good authentication, security. This is it's going to be a good option. Oh, I'm sorry, we have a chat here. Bear with me. Maybe not. Okay, cool. Thanks, John. Yeah, so DIN rail mounted, just like this one I'll show next. This has, again, this is just going to be bigger, more interface options. It's got a gigabit Ethernet switch built in, options for powering, dual power sources. That's very cool. Same level of encryption. But again, it's similar to the previous one, just a bigger, beefier unit to support more connections. And then this is one I'm really excited about. This one, IP55. This is the kind of thing you see on the outside of a wall, maybe under an overhang potentially, or a part of a roof. But this is when you want to provide Wi-Fi connectivity to a large area, potentially outside, exposed to some moisture, gigabit Ethernet support, as well as PoE support. So you run your Ethernet cable up to this with some PoE injected into it, and you've got power. You've got a powered, Wi-Fi access point in kind of the more, I guess, enterprise look and feel, at least, with that white enclosure and the 4 antennas. Again, supporting a better range, frankly, and concurrent 2.5 and 2.4 and 5G connection there. So just a kind of a cool example here, actually combining the ECI 6333 and the LTE module we talked about before. So on public transit buses, if you ever thought about this or noticed this, they get what's called route priority, so prioritization. So when a bus comes through an intersection, that signal needs to change, and they need to keep track of that vehicle as it's on its route to let passengers know, when the next bus is coming and so forth. So in this application, the Public Transit Agency has an ECI 6333 AC 2G, that white access point there, installed on a bus, and it's connected to an ICR 3241. So when that bus comes up to the traffic signal, it's communicating to that traffic signal 500 meters ahead of time, or 500 meters away, to say, hey, I'm coming, make the light turn green for me. And then that it's communicating that sort of locally, you might think, at the intersection level. But then where LTE comes in is that LTE is connecting the bus back to the central server at the transit agency. So that when the bus is en route or in service, it can get prioritization. When it's out of service, it can't get prioritization, right? And the routes can be changed or updated and so forth. So that's a combination of the ECI and the ICR in this case. Just maybe a little bit more detail on the rolling stock, this M12 connector type. Again, a lot of the differences here are in terms of form factor and the EN 50155 rating. So you wouldn't want to use an ECI 6333 AC 2G, let's say, on a freight rail car. It probably wouldn't work, right? It probably wouldn't meet the environmental specifications. But the ECI 60, specifically the EN 50155, that's for vibration, but it's also for some current, like isolation and transients and things like that. But there's a low voltage model, also a really high voltage model. Sometimes this higher DC is used on rails. Same enterprise security and authentication, same dual band concurrent capability as well. So very, very specialized, rugged device there. There's a few application examples here. I want to make sure we can go through these. These are pretty good, actually. Okay. I'll give you kind of an idea. In this case, this is actually a really, I like this because you're seeing, this slide in particular, you are seeing all of the Wi-Fi products that we just talked about, all used on one example. So you've got an ECI 6333 here, 6332. This is just one previous model used as the access point. Okay, and then you've got this ECI 6332 as a client here. The 1361 is a client, talking Modbus. That's a great fit for the 1361. And then some simple I/O. In this case, it's just reading the I/O from that stack light, and that's a great use case for the WISE 4060. So in one slide, if there was one slide where you wanted to see, okay, how does this all really work? You have two kind of client applications, I guess three with the 6332, and then this 6332 as an access point. Again, you can substitute 6333 there. It's just a slightly older model there. How about in a factory, right? So the AGVs, autonomous think it's autonomous ground vehicle, that's my understanding, roaming around a production facility here. On those AGVs, there's a PLC, right? And that PLC needs to talk to the Wi-Fi network, right, for the operation, right? So the 1361 in this case is always used connected to the AGV's PLC, and then it's handed off from one access point to another. 1361 is certainly good at that kind of handoff. The WISE 4000, 4050 might struggle with that, but the 1361 is probably better for that roaming type application. This is another AGV example. This is kind of picture like an Amazon warehouse here, where you've got these access points set up throughout the building, but the actual pick place machines here, these warehouse AGVs, again, as a server, these XE1362 as a wireless device server to the XE6333 access point. There's a lot going on there. Let's just focus on because that one's kind of similar to what we did before. Actually, one important thing here. At this facility, this is like a giant electrical appliance manufacturer in China. If you've ever been to one of these sites, you know there's dozens of buildings all spread out. The challenge here was to implement a remote monitoring system without having to rewire and redeploy all this. And you had a mix of both serial devices and wireless devices. So how do we connect all this? You bring in XE6333 series at each location, and then you're connecting this. You can see a Wi-Fi connection from the existing Wi-Fi client, essentially flow meters, power meters, or a serial connection, potentially as well, but then an Ethernet connection from the access point to the control room's network. All right. So a lot going on here, but just give you an idea of how flexible we can be. Yeah, this is the one that's not as relevant. Okay. I think this is the last example here. Okay, so a plastics company, this is in Taiwan. You can see, in this case, we set them up with directional antennas, surge arresters, antenna cabling, and then this access point to connect the Ethernet, essentially Ethernet switches wirelessly to the access points up to 500-meter transmission distance here. That's how you get these directional antennas and optimize that long range. Okay, we have one more session to go. Let's take a quick break. I got to grab a drink of water here. It's 3:38 Central. Let's come back. Well, we can do the stories fairly quickly. Let's come back. We'll start back up at 3:45 Central Time. Okay, so I'll send a note here. 3:45 Central Time. See you back at 3:45. Starting again at 3:45 p.m. CST. All right, and we'll do some stories. So I'll put on mute, and we'll get back together in about 5 or 6 minutes. Okay, it is 3:45 Central. I am sharing screen again, and I think we're ready to get started. So let me we'll get started here. Okay, this is our last session, gang, and we're going to be talking about customer stories. So this will be fairly quick, nothing super technical, no more part number lists and speeds and feeds and things like that. We're just going to tell some stories here. So we'll go through these stories, all right? And like I said, not super technical. Just the point here is to give you some ideas of the ways in which this technology that we've been talking about for the last almost 3 hours can be used in industrial and in energy and medical and all kinds of different applications, okay? So I'm actually going to skip right over the review stuff, all right? You'll have this, you know, all this good stuff, but you don't need to see that again. Okay, but I would ask yourself, as you're going through, as we're going through this together, do you have customers like this? And is there a common theme here? Okay, so be asking yourself. Okay. Remote monitoring of an industrial pallet wrapper. Okay, again, you might think, okay, well, I don't deal with any pallet wrapping customers, but I bet you that you have customers who have a machine on a remote site with a local PLC. In this case, Alan Bradley, I can't tell. This company makes money by putting pallet wrappers on customer sites and then selling the plastic wrap, okay? Why do they want to access this remotely? Well, they want to know how much plastic wrap is being used. They want to know how many wraps are being done per pallet, how fast it's rotating, because that would determine, you know, how fast it's rotating, and then how much is being used will determine how tightly the pallet's being wrapped, right? A lot of different data points like that. So they've got a web application that connects to the local HMI. Again, this has web access VPN written all over it, right? Connected through the SmartFlex to the local HMI device, and gathering this information, wrap cycles, the material, how much is being used, and so forth. Okay, SmartFlex industrial pallet wrapper. This is in the eastern United States. In the southern United States, we have a customer who uses this monitoring of automated roller belts, all right? Very similar to the other one. Automated roller belts are just like, you know, smart conveyor belts, basically. The local again, you notice the theme here. There's a web application connected to the SmartFlex, which is connected to the PLC. You might, okay, so what's the point of this? Well, these roller belts facilities, you know, they carry different things. So if it's moving loaves of bread, it's got a very different wear and tear cycle and maintenance, you know, requirements than if it's moving packages of brake pads or discs or something, right? Drums or whatever. I'm trying to say rotors. So customer needs to collect information on the throughput, the package weight, the temperature of the bearings, all kinds of different stuff that's collected by the PLC and then accessed by the web app over the SmartFlex, okay? Mentioned tunnel washers before, basically big commercial laundry machines. In this example, there's I/O data points being pulled off of the machine. This is connected to a local Wi-Fi network using the Y is 4050. Okay, remember that I/O to Wi-Fi? And then it's presented in a really slick web application to optimize OEE, prevent breakdowns, you know, schedule the maintenance. These are commercial laundry machines here, all right? And you can see an example of them there. Okay, this may be only relevant for those of us in the northern part of North America, but this is an example of monitoring an industrial snow melting machine. So sometime you folks that are on from Latin America, if you come up to visit us in Ohio or Minnesota or somewhere where we get a lot of snow, that snow doesn't melt on its own until the spring and summer, right? So when it falls on an airport or in a parking lot, you have to melt it. And so Trican is a company based in Canada that develops these industrial snow melting installations and equipment, and they need to monitor fuel level, the gate lifting and closing, temperature, obviously. And so they do that. Their remote software accesses it over the Advantech router, and then it's used to optimize that. And this is actually some photos from the field, in this case at Minneapolis-St. Paul Airport. Okay, we had a smart ag application example earlier. This is an example of the SmartFlex being used to optimize the GPS capability of Case New Holland. So this is a major global ag equipment manufacturer. In this case, the SmartFlex basically to get real precision ag. I mean, you can do turn-by-turn directions, but to get row-by-row, accuracy measured in inches, not just feet, you need to augment this. And so what this does is it is used to provide more accurate coordinates for the GPS computers that are used on the harvester, combines and tractors. Okay, a medical example here. So there's a eye surgery company in the Midwest U.S. that makes these, if you see on the right-hand side here, if you go in for like cataract surgery or some kind of corrective eye surgery, you'll see a piece of equipment like this. Inside of that device is an LTE gateway. We put a custom enclosure on it, but inside of this device is an LTE gateway. And what they do is they install these during the production process, ship them out to clinics and hospitals, and then they can remotely access that system to update it, to tweak the sensitivity of the lasers and the pedals that are involved. And overall, this gives the supplier, the medical equipment manufacturer, access to this equipment over the LTE connection. I showed this example before, I'll skip that. Okay, this is going to be the final example, and we'll finish up right around our time here. So, final example, New York City. We're doing elevator and escalator monitoring here. So our partner, Cloud Monitoring, they serve large building managers and building owners in monitoring elevators and escalators. So what you see on the right-hand side, you see this is like an elevator tower kind of. So this is where the elevator motor, the lift assembly and all that you see on the left-hand side. This is inside, so inward. On the left-hand side, this is a picture of the inside of that brick tower structure there, which is on top of an apartment building in New York City. So essentially, I won't go through all the text here, but basically, building managers are required to be able to know, they're required to get alarms whenever an elevator car is stuck. Let's say it's stuck between floors, or the door is stuck shut, God forbid, or the door is stuck open, which won't work either. And so they have to be able to monitor that. Here's how they do it. Okay, so on the left-hand side, you see this. This is obviously just a simplified image here, but the elevator car is going up and down. Here's the lift control and motors. That's making an RS-232 connection to the ICR. And then that ICR is basically polling Modbus registers for these alarm codes that are being thrown off by the PLC here. And this is sent to over the LTE network to an MQTT broker. The web app for cloud monitoring goes to that MQTT broker, gets the alarms, and then presents graphically on their web application what's going on. So if you were to zoom in here, you would see buildings all throughout New York City being monitored through this cloud monitoring web app, specifically elevators and escalators that are monitored through this app. LTE-M, awesome for the in-building penetration. the Python MQTT engine. This is sending that data, brokering that data anyway to the official broker. And then I mentioned earlier, there's that supercapacitor. So when the power goes out, that ICR sends a last gasp message. This is kind of tying in a lot of different elements of the LTE solutions we've been talking about before. Okay, so listen, now this is the end of our training. Now it's up to you. Go find your own. Shoot questions to your channel rep or to me. I'm happy to help. But we'll finish the training here. I want to thank everyone for joining. It's been a long training session. I'm going to stop. I'm going to process this video. We'll send it out with the decks and with the recording. And you are welcome to go about your day. I really appreciate it. Everyone have a good rest of your day. Thanks.